In the previous section, given n elements, we look for the number of permutations by arranging all n elements. However, in this section, we will learn to find the number of permutation of r elements only, r being smaller than n. That is to say, given n elements, we will only arrange r selected elements only, not all the n elements. An r permutation of a set of n elements is an ordered selection of r elements taken from n elements. It is denoted by NPR, which is governed by this formula. Do note that for this course, you will only be tested on r permutation of n distinct elements, but you will not be tested on cases where some of the n elements are of the same kinds. In part A, how many different ways can 3 of the letters of the word prize be chosen and written in a row? Well, the word prize has 5 distinct letters, but we only need to arrange 3 letters. So we draw only 3 boxes. How many choices are there for the first box? Well, there are 5 distinct letters, none of which have been used yet. So 5 choices, of which we pick 1. So how many choices here? 4. And how many here? 3. And the number of ways is equal to 5 times 4 times 3, or symbolized as 5p3, which is 60. In part B, how many different ways can this be done if the first letter must be a P? First, draw 3 boxes. The first box must be a P. Fill in the boxes with the special conditions first. So how many choices for this box? It can only be P, so 1 choice. So how many choices left for this box? Well, only P is used up, so there are still 4 letters. And how many choices here? 3. Hence, the number of ways is equal to 1 times 4 times 3, which is 12. In this example, a computer password can consist of 1 to 3 letters with repetition allowed. How many different passwords are possible? There are 3 cases here. Case 1, the password is 1 letter long. Case 2, the password is 2 letters long. Case 3, the password is 3 letters long. For case 1, we only need to draw 1 box. How many choices in that box? Well, there are 26 possibilities, A to Z. So 26 choices, of which we pick 1. For case 2, we need to draw 2 boxes. How many choices in this box? There are 26 choices here, of which we pick 1. What about this box? Well, since repetition is allowed, we can reuse the letter. So the possibilities are from A to Z again. So 26 choices again. For case 3, we need to draw 3 boxes. How many choices in this box? 26. What about this box? Well, repetition is allowed, so 26 again. And this box? Repetition is allowed again, so 26 again. By addition rule, the number of cases would be case 1 or case 2 or case 3. Since the keyword is or, we add up the cases, 26 plus 26 squared plus 26 cubed, to get 18,278. In summary, we learned to find the number of permutation of r selected elements given n distinct elements, or NPR. We may be asked to take care of some special conditions in such situations as well.